Hey guys, welcome to my channel, and in this video I'm going to cover a bit of problem called as majority element. So the problem statement is given an array, we need to find an element which appears more than half of the size of the array. So I'll solve this problem using two ways. So first way, I'm going to use hash map, get its frequency, and then find out which has the frequency more than half of the size of array. So time complexity of this algorithm is O of n, and space complexity is again O of n since we are using an hash map. So let's start with this. Unordered map. I'll just consider an unordered map. So yeah, I'll get the frequency from all from the array. That's done. I got all the frequencies now. I just need to check what all elements have, or it's a single element, so which element has less than more than the size of array or half of the size of array. I'll just directly return x dot first. I'll just return random element if that element is not present. So since nothing has mentioned in the problem statement, I'll return something int min. You can return -1 or something else, which has less probable of showing in this array, but either ways it's fine, I guess. So I'll just run this code and check. Okay, it's just a typo. Okay, seems like the code ran successfully. Next up, I'm going to start about Boyer-Morse voting problem. I don't know if the pronunciation is correct, but it's called Boyer-Morse voting problem. Okay, so in that problem, we just have to find the frequency for each and every element in an increasing manner, and if whoever stands at last of the whole iteration, that will be our majority element. So this problem only works if the majority element has a frequency more than half of the size of the array. So we just define count. I'll explain everything in detail after we ran successfully. So I'll define something called candidate, or who stands here. So we can we iterate through each and every element, and if count equals to 0, we replace the candidate. And what all other cases are there, like just have to take else if so I guess this shouldn't be there, because once we assign the candidate, we just have to increase that count. Okay, I guess this is wrong. candidate equals to nums of I, and count is obviously 0, but since we assign this number, we just have to increase the count. So just run the code and check how this works. Okay, use example test cases just in case. Okay, this also ran successfully. So basically, this is what happens. So we initially start with index 0, and at each and every time, if the element is present, like if the element repeats itself, we just increase its count, and if the element is not present, we just decrease its count. So since we have a condition that it appears more than n by 2 times, there is no way that the count will reduce more than half. Like count will reduce to 0 and it will assign some other candidate. So that case wouldn't be possible at all. So this is what happens. So when count is 0, we just assign a new candidate, and the count will automatically increase or decrease based on the number which comes from the iteration. And finally, we return the candidate after the whole iteration happens. So yeah, I guess that's it for this problem, guys. Thank you for watching, and if you have any queries or questions, please post in the comments below. Thank you for watching.